This video is brought to you by azamsharp.school, which is one of the biggest producers of iOS development videos. I mean, just check out this. 16 courses, more than 90 hours of videos, more than 90 hours of content, and it just keeps on increasing. So by the time you're watching these, it might be like 20 courses with 120 hours, all right? And now on Azam Sharp School, I do offer the annual membership, which is $249, and monthly membership, $25 a month. And what's great about these membership options is that once you sign up for these membership, you can access to all 16 courses and check out these amazing courses. Test-driven development in iOS, reactive programming combined, Swift Vapor, server-driven UI, Reality Kit, Swift Data Bootcamp. I mean, it just contains all the things that you need to become an amazing iOS developer. And I keep on adding more courses. So there are more courses that will be added later on. So this is an amazing deal. You can check out the testimonials from our existing students. And this is again one of the largest catalog for iOS development courses. So sign up for either a monthly membership or annual membership and enjoy all of these courses. Thank you so much. Let's go ahead and get back to the video. In this module, we'll be working on a project. This project is called News Application, and by creating the News Application, we will be using different aspects of async and await. First of all, we will use the URL session to connect to the News API, which is a web API service, to get all the sources of the news as well as the news for a particular resource. We will also use a continuation API so we can expose our existing functions as async and await. You will also learn a little bit about the MainActor, which allows your functions and properties to be automatically assigned and set on the main queue without using the dispatch queue. Here are some of the screenshots of the news application we'll be building. On the left side, you can see the news sources, which simply displays all the different news sources available from the News API. When you click on any of these sources, it will take you to the details and actual news articles for each source. And as I mentioned, we will be using the News API. So let's go ahead and get started. The best way to learn about async and await is to implement it in our application. I have already created a basic news application using the MVVM design pattern. Now, this application right now is not using any of the async and await features. Let's go ahead and take a look at the application. You can see on the right hand side, we have news sources, and all the different news sources are being fetched from the News API, which is a JSON API. And I can display all the different news sources. I can click on any of the source like CNN, and based on that source, we will go ahead and fetch the articles as well as the images associated with those articles. If I go ahead and select a different source like Engadget, you can see that it's going to load the images using the async image view, which is available in iOS 15, and it is going to display it. Let's go ahead and take a look at the code. We will start the app with the news list screen. This app is implemented using the MVVM design pattern. The reason that I'm not implementing the whole app again for you is that we're only trying to integrate and update our app so that our app can use the async and await. So it will be a waste of a lot of time to recreate the exact app again. You can see that this is a news source list screen, which is using the news source list view model. The news source view model uses the web service to fetch all the different sources, which includes BBC, ABC News, CNN, Engadget, TechCrunch, and many other sources. Once the sources are fetched, they're assigned to news sources, and then they're displayed on the screen, as you can see. You can see over here I have created the news source cell So this represents every single cell that you see displayed on the screen, which includes all of these cells. The whole application is following the MVVM design pattern. This means the view talks to the view model eventually talks to a service, and in the service we fetch all the different sources, or we fetch the news by the source ID. The URLs for our web services are inside the constant file. You can see that in order to use the news API, you do have to pass in the API key. Please make sure that you are passing your own API key, because by the time you are looking at this video, my API key may be expired. So this is our app. It contains two different functions: fetch sources, which is going to fetch all the different sources, and then when we click on a particular source, it's going to fetch the news based on the source ID. So maybe we clicked on TechCrunch or Engadget, and it will load and fetch all the news related to the source, TechCrunch or Engadget or CNN or BBC and things like that. So overall, it's a pretty simple master detail kind of an application. Another button that we have over here, which doesn't really do anything, is a refresh button. So if we click on the refresh button, nothing really happens. We are going to take a look at what the refresh button actually does. The images over here, as I mentioned, it is using the async image, which is available in iOS 15 and Xcode 13. You can take a look at the async image right over here. We will be using the async image so that the images can be fetched using the URL. As you can see in the web service, we are still using the result enum to send the value back. This is more of a callback that we are doing, and this is perfectly fine. One of the problems that we discussed earlier on that can happen whenever we are using these kind of callbacks is that we may forget to call return. And if we don't return, we will have the application in a limbo kind of a state. So our first step would be to look at these functions like fetch sources as well as fetch news, and look at them and try to convert them into the async and await functions. So let's go ahead and get started in the next lecture with the fetch sources functions, and we will see that how we can convert it into an async and await function. All right, everyone. So let's go ahead and get started with converting our fetch sources function into an async and await function. Now, instead of disturbing this function, I'm just going to go ahead and create a new function. Function fetch sources async. Now keep in mind that this is just for demo purposes. Eventually I will go and update the fetch sources function so it is actually using the correct async and await. We're going to be passing in the URL. Now, another thing that you can see that I'm not going to be passing in the completion handler, because that is the thing that we're trying to avoid, to use a callback. Now we can simply go ahead and return whatever we want to return, which in this case will be an array of news sources. Currently, this particular function is not really async. In order to make it async, we have to put the async keyword. Great. Now we can go ahead and construct a URL. We will go ahead and unwrap it. Guard let URL equals to URL, else. In this scenario, we can return something like probably an empty, or we can even throw an error. We will update that later on. Let's go ahead and return an empty array just so that we are not getting this error message anymore. Perfect. Now we can use URL session.shared.data, and you can see that in iOS 13 or in iOS 15 and Xcode 13, the Xcode team and the Swift team has added an overload function for async. This means that we can go ahead and pass in either a URL or a particular request. So let's go ahead and type this again. You will see that the another one that they have is the one that takes in the URL. We can pass in the URL over here. We don't really need a delegate. Now this function, if you look at the implementation, you can see that this is a data function that takes in a URL. The delegate is optional. It is async and it throws also. That's the important part. If it throws, then we have to use the try keyword. And since it's an async function, we will have to wait for it. It is eventually going to return us something, which can contain the data and also the response. We don't really care that much about the response per se, so we can ignore it. Now, even though we have used try, if we look over here, we will see that our function can't really throw exceptions. So let's go ahead and also make sure that our fetch sources async function is also capable of throwing errors by marking it with throws. At this point, our request is awaiting and it is suspended. Once that suspension is finished, meaning that we got all the data that we were looking for, we can go ahead and use the data to decode. And that process is pretty similar because we will simply be using the JSON decoder dot decode the data. We will decode the data into a type called news source response, which we have already done, .self. We will simply go ahead and pass in the data. This can also blow up, so we're going to go ahead and call with a try. You can also use try question mark or try optional. If you want to do that, that's perfectly fine also. And then we will get a news source response. This is exactly similar to what we were doing before. Now that we got the response, in this response will be something that we can send. So we can say news response dot, and over here we need to see what property do we have. So you can see that over here we are sending the sources. So we can go ahead and send the sources. If the sources are not available, then we can go ahead and send an empty array. And there you have it. You can see that our async function is definitely much less lines of code as compared to fetch sources. Also, the function that we have has a very nice and straightforward path. Let's go ahead and try to use this function, fetch sources async. We will use it from inside our news sources list view model. If you try to call fetch sources async, let's go ahead and we can comment this one out. There we go. And try to call web service dot fetch sources async, passing in the URL, which we do have, constants dot urls dot sources. You will see that since the fetch sources async is marked with an async, you cannot await for it. So in order to call this function, you need to make sure that your get sources function is also marked with async. And now you can await the result. But fetch sources also can throw an error. So we need to make sure that we cache that error. This time we will also use try await. But try cannot just happen like that. I mean, you have to put it somewhere unless you're using try optional or try exclamation mark for forceful try. We will not do those things. We will be a little bit more protective and we will put it inside the do catch. This means that if there is any error, we will simply go ahead and print it out. Now the fetch sources async is going to return you something, which will be an array of news article or news sources in this case. So let's go ahead and get all those news sources. Once we have the news sources, we can map through them and we can assign it to the news sources on the top, which is of type news source view model. These news sources that we have right now, these are the actual model objects, and we don't really want them to expose to the view. The view will only deal with the view model itself. So there are a couple of different options. We can go ahead and pretty much copy these lines that we originally had, where we are iterating through the news sources and we are assigning it to news sources. Now, if we go ahead and run the app, we will get an error. Let's go ahead and see why we're getting the error. Interesting. Since the get sources is now an async function, and over here we have to await for it, this whole closure should also be async. If it's not, then we won't be able to call that. So what can be the solution for this problem? Well, luckily in Xcode 13 and iOS 15, the iOS team and the Xcode team has introduced a new closure. This is called the task closure. And task closure is kind of similar to the onAppear, but it's a little bit different also. Task closure is mainly used if you want to perform some sort of an async task when your view is actually loaded. You can see over here your task closure is already marked with async. This means that you can await inside it. So let's go ahead and use a task closure instead of onAppear. Now I can go ahead and perform await, and I can move all of this code inside task closure. We can even go ahead and remove onAppear. Perfect. Just because we have introduced task closure, it does not really mean that onAppear is going away. At this particular moment, there are no plans for the await or the onAppear to go away. But if you want to perform some sort of a task when your view is actually loaded, then start using task closure or task, because it is already marked with async, which means that inside the task closure you can await. Let's go ahead and try to resume and see if we can fetch all of our sources. Looks good. We can fetch all the different sources that we have. If we click on the source, it can even go and fetch the articles. So this time we have converted our fetch sources function into fetch sources async. Now, it's not really a good idea to have like an async function and a fetch sources function. It's very confusing. What we would like to do is just use fetch sources, and we should just get away with fetch sources over here. So let's go ahead and try to comment out this. If we build this, it's fine because we're not even using fetch sources. Now we can go ahead and change the name over here to fetch sources, and we can remove the old fetch sources. Make sure that we update the references everywhere. I think we're calling it somewhere from here, which we can go and try to update. Perfect. So this takes care of fetch sources, and fetch sources is now updated to use async and await. The next task that we have is to update fetch news. We can use the same exact technique to update fetch news, but let's take a look at a different way of updating fetch news, where we will make sure that the fetch news function still remains. What does that even mean? Why can't we just go ahead and update fetch news just like fetch sources? Well, we can, but let's just assume that fetch sources is some sort of a third-party function that we don't have any access to. And in order to update that, we have to use a different terminology and different way, which is known as continuation in async and await. So let's go ahead and learn about continuation and how we can use continuation to perform a request to our existing fetch news function, which is a callback function. Welcome back, everyone. Let's go ahead and get started and learn about the main actor in Swift language. Now, here's a simple application. You can see that I have created a service which goes to a JSON placeholder URL and it retrieves all the to-do items. I have created a to-do model class which consists of the ID, title, and completed properties. And I also have a to-do list view model that uses the web service, get all the tasks, and finally sets the to-dos property, which is declared on line number 12 with all the different to-dos item. Make sure that you understand that the to-dos property on line number 12 is marked with published attribute. What will happen if I try to run the application right now? So if I run the application, it works perfectly fine. It displays all the different to-do items, but you can see behind the scene, it is telling me that there's something wrong. Publishing the changes from the background thread because the web service is using callbacks and then the callback happens on the background thread. And we're trying to change the to-dos property, which is marked with publish, on the background thread. So that is not really allowed. You shouldn't be doing that because it can create some weird kind of results and sometimes even it can break the app. So what can we do to solve this problem? Well, in our case, we can simply go ahead and write dispatch.main.async, which is basically meaning that we are switching to the main queue, the UI queue or the thread. And now we will set the to-dos property, which is marked with published property wrapper, and we will change it, assign it on the main thread. You can see that now the error or the warning is now gone. Great. In iOS 15, we have now introduced a new way of setting these properties. One thing to keep in mind is that the main actor that is introduced in iOS 15 works the best if you are using structured concurrency using async and await features, which was introduced in the new version of Swift language. So right now you can see that we are not using async and await. We're simply using the plain old callbacks. So in this particular model, although it can work, it's not really going to be that beneficial. But let's go ahead and see how it will work. If I go ahead and mark main actor on my to-do list view model, then it's basically saying that anytime we are going to use or set publish property or any of the property in any of the function, we're going to call on the to-do list view model, it should automatically set on the main thread. If I go ahead and try to run this application just by marking the main actor, we can see that it doesn't really work. It's giving us the same exact issue, even though we have marked over here that this is the main actor. So this is what I'm talking about, that the main actor and the property wrapper and everything related to the main actor will work really great if you are not using the callbacks, but you're using the structured concurrency using async and await. In async and await model, and if our function getAllToDos was using async and await, then everything would have worked as expected. But it's not. It's using the classic old callbacks. So our option with callbacks are a little bit different. We can go ahead and use the dispatch queue.main.async. That is fine. Or we have to make sure that we are setting this particular to-dos property on the actual main thread. So how can we do that? Well, one of the ways you can do that is to call the MainActor.run closure. In MainActor.run, you can simply set this particular property. MainActor.run requires an async, so we will have to make sure that we are calling it with await. We cannot really wait on anything when we are not inside the async context, so now we have to wrap it again with the task. If I go ahead and build this, and try to run it again, then you will see that it's not really going to give us any of those warnings that we saw before, because now the to-dos is assigned on the main thread. But you can see that we had to write extra lines to get that to happen. It will be much easier if we just use dispatch queue.main.async in this case. Another way of setting everything on the main thread is by using the actual closure itself, which is being returned from the web service. With escaping, we can go ahead and mark with MainActor. Now, if I go ahead and build the application, I will get this following error. Basically, it is saying that now the completion is marked with MainActor, so you need to call this in isolation. So if it's a MainActor, that means we can await for it, but we can't really await for anything because we are not inside a task. So let's go ahead and put it inside a task. And we have to do this for every single piece. So we will put an await for it. So you can see that our work is much more than it was earlier. And the only reason that we had to do all of this different work is that we are not really using structured concurrency in Swift language. We're just trying to cover up for our callback functions. After this, you can see that everything is now going to be firing on the main actor or on the main thread. Now I can go back and I can simply run the application without writing anything associated over here, and it will always work correctly because everything is fired. The closure, the completion closure, is actually fired on the main thread. So we don't really have to do anything. This is not really a very good solution because we had to type a lot of code for this to happen. This is just to show that if you want that approach, you can pass the main actor as a property wrapper on the closure itself. But I don't think that's a very good solution. So I'm just going to remove that part. This means that we have to remove all of these different things, the await and the task, everywhere that we have used. So this was just to show you that it can be done, not that you should do it. All right. The main actor can also be decorated on the actual functions. This means that the populate to-dos function is going to be fired on the main actor. Again, this feature is only going to work if we are using the complete concurrency model of the Swift language. So right now, the populate to-dos is not really going to be doing anything on the main function. I mean, it will be called on the main thread, but once you go inside the closure of web service, then again, we're back to the background thread. So just by marking this with main actor doesn't mean that your to-dos property, which is marked with publish, is going to be set on the main thread, as you can see the problem. Now, one of the great ways that you can solve this problem, and we have already seen, we can use dispatch queue.main, we can use a MainActor.run, we can use the completion block that we saw over here by marking with MainActor. But if you want to go for future, then I would just try to change getAllToDos into an async function. So let's go ahead and create an async function for getAllToDos. So I'm going to begin right over here. And just to name it a little bit differently, I will call it getAllToDos async. Please make sure that if you are writing this in your actual application, I would not add async keyword. This is just to show that this is not colliding with the original name that we had. Since this is an async function, I'm not really going to be passing in any callbacks. I will be, however, saying async throws because it can throw something. It will eventually return me an array of to-do objects. Great. So let's go ahead and get started. The first thing we need to do is we need to make sure that we have the URL, which we do because that is being passed. That's great. Next up, we can go ahead and say URL session.shared.data. And in the data, we can pass in the actual URL. So there we go. The URL session.shared is a async function. This means we can await for it. So let's go ahead and put await. And it can also blow up. So we're going to use try. we will get something back, which will be data and a response back. Much nicer. And now we can go ahead and decode the response. So JSON decoder dot decode, and we are decoding a to-do list. So to-do dot self, an array. We will pass in the data. This is going to return us a list of to-dos, I believe. And now in the end, we can go ahead and return to-dos. The try over here, or the JSON decoder, this can also blow up. So we will make sure that it's not really blowing up. And if there's a problem, we can either return to-dos or an empty array. So this is our function. All right. Now let's go ahead and call this function. So this is called the get all to-dos async. So I'm going to go back over here. I'm going to remove the main actor and everything. The URL, I believe, is fine. That is perfectly okay. The web service call is going to be a little bit different. So web service dot get all to-dos async, passing in the URL, and it is going to return us to-dos. We will have to await for the function to get it returned. We can't really await for the function because our function populate all to-dos is not marked with async. So let's go ahead and mark this with async. Also, our function get all to-dos async can throw an exception. So we need to make sure that we are calling it with try. Hopefully it will return us all the to-dos. And once it does return us all the to-dos, we can perform a map function on it. And we can try to convert it to to-do view model.init. This is going to give us all the different to-dos. Perfect. So this to-dos that we have assigned is the one that we have created right over here, which is also marked with published. Keep that in mind. Let's go ahead and run the application. And we'll see that if it is allowing us to display everything or not. Okay, so currently we are getting an error. And this is the error that we are getting. Let's remove this part. So on the on up here, we're trying to call populate all to-dos, but in order to call populate all to-dos, since now it's an async function, we have to await for it. We don't have to use on up here. We can now start using task, which is already marked with async closure. If I go ahead and type it again, you can actually see task right over here. You can see that it is already marked with async. So it's an async closure. This means I can await inside this particular closure. And if I'm awaiting, I would probably use the await keyword also. Now let's go ahead and run this. Okay, so it's running fine. Let's go over here. There we go. So everything appears to be working just fine. We didn't even use MainActor. If we go ahead and run our application, you saw that it is running perfectly fine. It didn't really give us any error, and it didn't say that you were setting the to-dos property on the different background thread. And the reason is because we are inside the async function and we are awaiting for this particular result. And the await happens on the main, on the UI thread. So once the thread is resumed, we're back to the main thread on which we set the property, which is to-dos. Great. But what happens if we didn't really make the call on the main thread? What happens then? So let's take a look at that scenario. What about if I go ahead and say task.detached and try to perform that inside task.detached? Now, this basically means that it's definitely not going to be on the main thread. It's going to be some other thread. And you can also check that if you print out the property, if you just simply say thread.isMainThread, it is going to print out false because this is not the main thread. Let's go ahead and comment out these two things so we can just see that if we are inside the task.detach, what it is printing out. And you can see right there, it is printing out false. So this means that it is not on the main thread. when we are inside task.detached closure. What about if we try to run the code now and keep everything the same? So we are making this call on some other background thread, and we are trying to set this on probably the background thread or some other thread. Now, back again, we are faced with the same exact issue. Publishing changes from the background thread is not allowed, right? Now, what happens if we go to the to-do list view model and if we are using the latest feature of MainActor? And that is the difference that we are trying to see. Since I have decorated this with the MainActor, it is telling us right on the spot that, hey, this is really not allowed. What you're trying to do is not allowed. You're trying to set something which is marked with MainActor, and you're trying to set it inside a background thread. And the reason it is complaining is also because we have marked the property wrapper or decorated the property wrapper on the to-do list view model. This means that every single property and every single function inside the to-do list view model must be called on the main thread. And that's exactly what we are not doing. We're not really calling it on the main thread. Now, this code is obviously something that you will not write because we are trying to move it to the background thread and trying to make the call. But if that ever happens, and if you see ever this kind of an error, this is basically suggesting that you're trying to call something, but that something is not on the main thread. So you have to jump onto the main thread. So how do we jump on the main thread? Well, we can use the MainActor.run, and we can make sure that this is run on the main thread. All right. Now we have done that. Let's go ahead and run this application. You can see that you're no longer getting that error because we have switched the thread, and now we are making sure that the closure is performing on the main thread. In your actual application, I don't really think that you will be using task.detached. This is just to show you that if you were performing a call on the background thread or not on the main thread, then the context that is set for that particular function for the async is not the main thread, it's the background thread. If you go inside the closure, which is MainActor.run, and try to print out that if this is on the main thread, then you will eventually get that yes, it is the main thread that we're running on. And that is why it never really complains. So the MainActor property wrapper allows you to make sure that the properties, the function, or both of them are actually running on the main thread. Just by decorating it with the property wrapper doesn't really make sure that they are running on the main thread. That's still your responsibility. But if you are trying to do some weird stuff like the one that we are doing, trying to execute code inside task.detach, which is a background thread, then instead of a runtime error, it's going to be a compile time error where your compiler is going to tell you that, hey, what are you doing? You have marked this with MainActor and you're trying to set a property. Please make sure that the property is set on the main thread and not on the background thread. So it becomes your responsibility. All right. So that's the whole point of the MainActor. It is going to be watching you. The compiler will be looking at your code, and it will, if it sees that you're trying to set some property, whether it is the to-dos or whether you're calling populate to-dos in a background thread, then it will complain. So there you have it. This is the new feature of Swift language, MainActors in Swift. All right, so now let's go back to our refresh button. Inside the refresh button, we want to go ahead and call new source list.getSources, which may return us some new sources. Let's go ahead and try it out. We will say await new sources list view model.getSources. If I go ahead and try to run this, I can't really do that. And the reason I can't do that is that you can only call await inside an async function. But at this moment, we are not really inside an async function. Well, we're not really inside an async closure also. So you can't call a async function and await for it when you're not in the context of the async function. So how can we fix this problem? Now you'll be very happy to find that there is an easy way to fix it. Simply wrap your call with async closure. Async closure will be executed instantly, and anything inside the async closure can await the result from an async function. Now keep in mind that there are talks that the async keyword will be replaced by task or something else. So if that happens, I will create an additional video that will show you the new and updated syntax. But at this particular moment, async is the async closure, which allows you to await for the result from an async function. And now, since we have added the async, await is not going to give us an issue, even though we are inside a synchronous code, but it is wrapped with an async closure. Let's go ahead and run this. Since we don't really have any new sources added, it's going to produce the same exact result. But we saw that we can, if we want to, from synchronous code, call asynchronous code, which is using async and await by using the async closure. So in this section, you learn about the new async and await features. And I really hope that you have enjoyed these features, and looking at the future of Swift language, async and await will be a big part of the language itself. Now async and await is available in URL session, notification, health kit, and even core data. Thank you so much.